Alright, so we're going to show you how to analyze the data that you collected on the calorimeter. Okay? So what we do is, first of all, we go to this little button right here. Now, if this isn't up for some reason, the analysis software is this Proteus analysis link right here. Okay? So we bring it up, and you're going to usually start with nothing here. Actually, I gotta cancel out of, close out of all this stuff here. Unload all files. Don't save. All right. So I'm going to open up a file. So we go into where we're saving our files, and our files were in. Let's see. Go to the computer here. The C drive under the niche. Proteus 61, and then data. Alright, and that's where your files are here. So you have Sam's group, Nick's group, Teresa and Brianna's group. Okay? So we'll start with Nick's here. Alright, so we double click on Nick's, and it brings up the data. And this red one here corresponds to this red axis here, which is temperature. The blue one here corresponds to this axis over here, which is the change in the microvolts or energy necessary to cause this change in temperature to occur. Alright? And what we're looking for is we're going to take the slope of each one of these little heating curves. And we're seeing if that slope changes over time and if that change is consistent with the growth of bacteria. So after we get up the data here, we go into extras. We go into export results, and we're going to just going to open up this, and this should have, we're going to use it on full range there. Let's see. Do I have this set up right? Oh, yeah, you have to make sure that I clicked on change here. You have to make sure that you have the CSV one there, and we're going to be going to the file. Seems like I'm missing something. Extras, export data, is that what I did? Oh, that's the problem. Okay, let's try again. Extras, export data. There we go. Alright, so now this should all be set up for us. All we have to do is press export. So when we push export, it's going to try to save it somewhere. I'll put it on here. I'll call it test. Alright, so I'm going to put it on the desktop. Oops, what did I do? Oh, did I make a new file in test? Oh, no. Okay, so go back here. I'm going to... let's just call it 1. There we go. So I saved it on the desktop, and now I can open it, view the file, and it will open it in Excel. Okay? So this top set of, or top amount of rows here are just kind of information about the run, so I can delete those. And then I don't need the gas flow, and I don't need the sensitivity. I can delete those. I also don't need the temperature. I can delete that. Wait, can I delete that? Yeah. I just want this information: the time, the DSC, and the segment. Time, the energy, and the segment. So I have this analysis template here, and essentially what you're going to do, actually we won't use the analysis template, we'll just work straight from here. What you're going to do here is you're going to type the number 100, and you're going to drag it down all the way to the bottom of the 16th second. Okay? And then you're going to go back here and go to the bottom of the first segment. The first segment here, these hundreds are just space fillers. You're not going to be using any value that has 100 on it. But at the bottom of each one of these segments, the bottom of 1, for example, here, this is, I can see the Well, let's see. Let's go back really quick. I can see the temperature here is heating, right? Temperature is changing, is going up throughout this first segment. And then it gets to a maximum here, and then it starts going back down. Oh, no, let's see. It didn't reach the maximum until about here, but that's alright. That's just because it was kind of catching up. So then the temperature starts going back down. So we want the odd segments. This first segment is the heating segment. The second one is the cooling. The third is going to be the reheating. So every odd one is going to be the heating segment that we're after. So now we can say 100, and we just double click on this and it'll fill it all the way to the bottom. And then we go to the bottom of our first segment, and what we want to type is here our line_est program. So we double click on line_est, and it asks for the known y's, and the y's are going to be our not the time, which is here, but the DSC. So those are our known y's. I push comma, and now it's asking for the known x's. So these are my known x's. Alright, and then I go comma, true, comma, true. Right? And then I push enter, and now this is the slope of this XY data. Alright, and that corresponds to this first, let's see, which one is this one? That corresponds to this little thing here, so it's probably not going to be useful. The second one comes down here. The third one is the one that's really going to be useful. The fourth one, the fifth one, sixth one, seventh one. So we want the odd ones. The third, the fifth, the sixth. You can click on these segments, and it'll just, let's cancel here. You can click on these segments, and it'll just highlight one little section of the segment. Okay? So it essentially found the slope of this first little portion right here, which again is just it kind of warming up and getting ready. But the third one here will be what we want. So, now, now we have a bunch of 100s, right? And then it goes at the end of this first segment, it takes the slope of this time and the energy. So I'm going to highlight all of this down to the second segment, right there, and I want to essentially drag all of this down to the very bottom now, because then it'll copy all of what I had up above. There we go. So now if I go to the bottom of every odd segment, it should tell me the slope for that segment. So here's the bottom of the 13th segment, and so forth. So there's the bottom of the 11th. So I have all the odd segments now labeled. And so now I can take this information here, copy it, and I'm going to just paste the values right here. So these are the values. And now I'm going to, I don't need time anymore. Well, actually no, I do need time. There's no need temperature, but I didn't take temperature. So I do need time. I don't need the segment anymore, and I don't need the DSC anymore. Because I pasted the values, then this is just the value. If I look up here, this one is the equation for this one over here, but I've just pasted the values over here. So now I can take these two here, and I can sort them by this J column here, which is labeled 100, and I say OK, smallest to largest, and now only the ones that got slopes show up. All the rest of these that are 100 are down below. So now this is the time that corresponds to when the slope was taken. So then I can just take this information here, paste it, and I can insert a scatter plot there, and we can see how the data changes over time. Now that first segment is not going to be of interest for us, so we'll get rid of it. And you can see how the slope changes over time. And what we're interested in is the 10th to the 30th minute in terms of slope. So we don't need to take this. Oh, this is the 7th minute. Where is it at? Oh, okay. I forgot. I need to take these here. If I can just take these two columns, I need to go data, sort, cancel. I need to insert some headers for these. So this is going to be time, and this one is going to be slope. I need to order these according to time. So there we go. Now if I right click on this and add a trend line, there we go. And I also don't need this 5-minute one. I'm just interested from 10 to about 30 minutes. Alright, so that data there, this slope here, I'm going to look at its rate, and then we're going to compare this to an LB sample. Alright, and the LB sample, we're going to see if the change in the slope for the LB sample is different than the change in the slope for the E. coli sample. That makes sense? So you do this exact same thing with your LB sample. You're going to have another graph just like this one. You can overlay them if you want to. And really it's this slope value here that we want to see. If the LB required just as much energy to heat it up. Alright? Get it? Good job.